Greetings once again, guys, and welcome to another awesome edition by ICampSA. In this edition, we are going to be looking at problem set 7, which is our practice problem, and this is from the 2019 May-June examination paper. 3.1 reads, the first three terms of an arithmetic sequence are as follows. And then 3.1.1 requires us to show that P is 11. So let's go ahead and deal with that. So let's look at 3.1.1. We are told that what we have is 2p plus 3. That's the first term. The second one is p plus 6. The third one is p minus 2, and so on. So what is it which we know? Well, it's an arithmetic sequence as told here. So what that means is the difference between these terms is equal. So if you observe carefully, the difference here will just be p plus 6 minus 2p plus 3. And then on the other one, it will be p minus 2 minus p minus 6. And the answers will simply be, if you subtract, you will see that you will end up getting negative p plus 3. And then on this one, we will end up getting, if you look carefully, the p's will cancel, and then we'll end up getting a negative 8. So there's a positive there. So it will become negative 8. So what we know about our common difference is that it will be equal. So our d will be negative p plus 3, but it will also be equal to negative 8. So what we can do is to go ahead and solve for p, where we have negative p plus 3 equals negative 8. And what we can do to solve for p, you can transpose the p and then transpose the minus 8, such that your answer becomes p is 11. So your p will just be 3 plus 8, of which the answer is 11. So our answer is p is 11. So we've shown how we get that. Then the next question, 3.1.2, we are required to calculate the smallest value for n for which Tn will be less than negative 55. So we need to first determine what is Tn. So Tn is a plus n minus 1 times d. And this is the standard form whenever we are given an arithmetic sequence. So a, we can clearly see that a, the first term, is just 2p plus 3. So we can find it. The p, remember, is 11 plus 3. So if you look carefully, our a will be 25. So that is our first term. And then for d, we can use any of these expressions. So if you look carefully, we have 1, which tells us that our d is negative 8 when we take this difference. So we already have negative 8. So therefore, we can go ahead and find Tn, which is, for the a, we have 25 plus n minus 1 multiplied by negative 8, of which, if you observe carefully, our Tn will be 25 minus 8n, then plus 8. So the final answer for Tn will just be negative 8n plus, if you observe carefully, 33. So this is what Tn is. So we need Tn to be less than negative 55. So what this means is we'll have negative, remember, we require Tn to be less than negative 55. But that is going to be, it's negative 8n plus 33 less than negative 55. So what does that mean? It means we have negative 8n less than negative 55. And then when we transpose this 33 to the other side, it just becomes negative 33. So we end up having negative 55, negative 33. So this ends up becoming negative 8n less than negative 88. So we know that we want to solve for n, but not negative 8n. So we'll divide by negative 8, divide by negative 8. And remember, whenever you divide by a negative, the sign changes. So our n becomes greater than negative 88 divided by negative 8, of which the answer becomes n is greater than 11. But remember, they mentioned that they want the smallest n value. The smallest value of n. So if we observe carefully now, what is going to be the smallest value of n if our n must just be bigger than 11? So this means our answer must be 12. Because from 11, 12 is the number that just follows afterwards. So our answer will be n is 12. Because they said the smallest n value. And we are getting that n must be bigger than 11. Okay. Done with that, let's go and have a look at the next question. So this answers 3.1.2. Essentially, this question. So the next question we need to look at is question 3.2. So let's focus on it on the next page. So what we are given is two sums, really, and we are required to evaluate the third one. So what I'm going to do is to focus on the sum here, the first one, which is that we have k is 1 up to 6, and the equation we have is x minus 3k. So the question we need to ask ourselves is, what is the sum here? We can clearly see that it is a sum of 6 terms, because what we have is 6 there. Okay, but what is the sum? So what I can do is to get T1. So T1, you just put k is 1 there. It's going to be x minus 3 times 1. So it's just going to be x minus 3. And the last term is T6. So we can put x minus 3 times 6 there, which is going to give us x minus 18. So what we can then do is to use the formula, if you remember, Sn is n over 2 into a, which is the first term, plus the last term. So what you should be able to see is that here we have a, which is the first term, and here we have the last term of the sequence. So this means that our S6 will simply be, we have 6 terms divided by 2, and we'll have x minus 3 plus x minus 18, like that. So that is what we have. So if you solve for this, you'll see that the sum of the 6 terms will give us 3 into. So it will be 3 into, if you observe carefully, 2x minus 21. Of which this, if you quickly multiply, you'll get 6x minus 63. Okay, that is what we get. Then now let's focus on the other side, which is the other side of the sum, where what we have is we are summing from k is 1, but we are summing 9 terms. And what we have is exactly the same expression. We have x minus 3k. So what we can clearly see is that we are doing the sum of 9 terms here. Okay? And we can go and use exactly the same method which we just did. So if you go and find term 1, it will be the same. You will see that it will be x minus 3, which will just give us a. But we'll need the last term, which is term 9, which will be x minus 3 times 9, which will end up being x minus 27. And this will be the last term. So it means I can now use our formula Sn, which is n over 2, into the first term plus L, which is the last term. So our sum of 9 terms will just be 9 over 2 into, maybe let me put it down. So our S of 9 terms will be 9 over 2 into the first term is x minus 3. The last term is x minus 27. And you will see that our S9 will be equal to 9x minus 135. So if you go ahead and do the maths, you will see that 9x is equal, so you'll see that S9 is 9x minus 135. But we are given something. If you look at the left-hand side and the right-hand side, we are told that this S6 and S9 are equal. So I can go ahead and take S6, which is 6x minus 63, and equate it to 9x minus 135. And what we can do here is really to solve for x. So we can transpose that to that side and then take this one to this side, such that what we are going to end up having will be 3x on the other side. Then when we transpose the 135, you will see that we'll get 24. Sorry about that. 135 minus 63, that will give us 72. Okay, but then we know that we are looking for x, so we can divide by 3, and what you will see is that the value of x which you obtain will be 24. So now that we have 24, what are we going to do with the x? Now what we are going to do is we are going to sub x into the third sum, which is what we are trying to show, that it will actually amount to 0. So this means the third sum, which is from 1 up until 15, which is x minus 3k, this we can just plug in the x already, and then it just becomes the sum from 1 up until 15. But what we are summing there is just 24 minus 3k. So we'll go to the next page and evaluate this. So now if you observe carefully with the sum here, all what we are doing is we are doing the sum of 15 terms. So we're doing sum of 15 terms, and all what I need to do is to figure out what is the first term, of which it is just going to be 24 minus 3 into 1. So the first term, if you observe carefully, will be 21. And then I need the last term, which will be term 15. This will be L, so it will be 24 minus 3 times 15. And this will be equal to, minus 21. So now that I have this, I remember that we have the sum of n terms, which is always given by n divided by 2a plus L, where L is the last term. So for our problem, what we therefore have is the sum of 15 terms is equal to, if you look carefully, we need to have 15 over 2 into the first term is 21 plus the last term is minus 21. And if you look carefully, what is inside there is going to sum to 0. So essentially our sum of 15 terms will just be 15 over 2 multiplied by 0, which is equal to 0. And this is exactly what we were required to prove if you look at the question here. So that is what we were required to prove, and we found it. So that is what was expected of us in this question. And make sure that you do keep yourself paced very well. You were required to take 10 minutes, but because we are explaining, we take a bit longer.